Hi there, I'm Moritz from the Acodis machine learning team, and today we would like to share some insights on a recent project of ours. In this project, we have been dealing with a large corpus of technical documents, and one of the tasks was to identify duplicate entries. Now, as you can imagine, many companies store information on their technical infrastructure in such databases, which will then contain manuals, protocols, and technical drawings. However, this information is often stored in an unstructured way, such that retrieving information is difficult in the first place. Now, as the database grows, so will the number of sources of documents, which could be scans, native PDFs, email attachments, and so on. And this will also lead to an inevitably growing number of duplicate entries in the database. Now, this is on the one hand a waste of resources, but on the other hand, it also makes it difficult to retrieve the relevant information simply because you have a large number of duplicated information in your database. And to give you an idea of the complexity of the task, if you want to do this manually, say you have a database of 1,000 documents, then comparing every document to any other document would entail about 500,000 comparisons. And if you're fast and one comparison takes you 3 seconds, you'd be spending 400 hours on this task. So it's very desirable to automate this task and find a way that makes it more efficient. So how did we go about this? Well, first of all, we tried to use a text-based comparison of documents and applied what is called latent semantic analysis. This is fast and it typically works well for documents that contain a lot of text that is unique. However, if we have documents with large amounts of standardized text, such as protocols and drawings, this will fail many times and produce false positive predictions. In a second step, we try to use an image-based comparison, which is more accurate on these documents with standardized text. However, it's typically very slow, so it's not very feasible to apply to the entire database. And often, scanned documents are missed. So what we came up with in the end is an unsupervised approach, because we also didn't have any annotations of duplicates, that is hybrid. So first of all, we use a text-based pre-selection of duplicate candidates and then apply an image-based vetoing system to remove false positive predictions. How does the text-based analysis work? Well, first of all, we capture the content of each document either by directly extracting it from a native PDF or by applying optical character recognition. We then tokenize and vectorize the text, that is, we map words to numbers, and finally we apply some dimensionality reduction to map every document into a common vector space, in which we then apply a similarity measure between document vectors in order to compare how similar two documents are. Now here's an example in which you can see a manual. It's 8 pages long. It contains lots of text, and this is easily identified as a duplicate. You can see we actually found 4 entries of this in the database, each with its distinct document ID. So it's indeed different database entries. However, it is the same document. Now, we were also able to retrieve handwritten document duplicates, in this case, a drawing. And if you look at the extracted information, it's actually useless because the optical character recognition doesn't work very well with handwritten documents. However, it extracts the same information from both documents, and therefore we were able to compare these and make correct duplicate predictions. Now, the limitations of this text-based extraction, as I said, comes when we have, for example, technical drawings, which contain standardized text. These 2 documents were identified as duplicates. However, you can see the mechanical part that is depicted clearly has different measures, different layout, and a different drawing number. So it's not the same document. And we go about this by doing the following steps. First of all, we mask the text in the document since we already used this information. And we then apply the so-called SIFT algorithm to identify key points in the images. We then match the key points of both images with each other, and in the case where we find a large number of matching key points, we can be very confident that this is indeed a duplicate. However, in the converse case, where not many key points are matching, we can throw a veto and say this is actually a false positive duplicate. And in the case of these 2 technical drawings, we found just about 50% matching key points, so we would correctly throw a veto in this case. Now, also this approach has some limitations, namely when we have scanned documents. On the right top, you can see two documents, again, duplicates and identified as such by our text-based comparison. However, the images in the document have very different brightness and contrast levels. This inhibits the key point extraction and in the end would throw a false veto. Now what we've done here is we've tuned the hyperparameters of our image-based feature extractor to have about 80% matching key points on page 1 of this document. However, if we then go to a page 12 in this document, which you can see on the bottom, you see that only 12% of the key points in both pages are actually matching. So this generalizes very poorly even within the same document and would throw many false vetoes. So what we do is we identify scanned documents, and if a veto is thrown, we give a user warning that this duplicate entry needs to be manually verified. So to sum up, we've devised a dedicated algorithm to detect duplicate entries in technical document databases by first applying a latent space analysis of text features and subsequently extracting image features for vetoing false positives in the case that we have standardized text such as in technical drawings and protocols. Finally, we've added a scan detection to give a user warning in the case where the scanned document could be a false positive simply because of different contrast and brightness level. And while this still involves some manual labor, you can imagine that the complexity of the task is greatly reduced because now we don't have hundreds of thousands comparisons to be made, but just a few dozens for the scanned documents. So thanks a lot for watching and see you soon.